Hi everyone, I've had some people ask me about how to solve the worksheet that I've put up to prepare you for your graphs and functions methods stack, which the worksheet is called Burning Up. I know that there are answers already to the bird flight path one, so we'll talk about how to approach this task and hopefully it will help you prepare for your real one when we get back from all of this. So, what we have to remember is that all of these functions have dilation factors that we aren't told. However, we know enough information about them. So the first question there is find the equation of a truncus function that passes through those three values. So what we have to do is we first of all have to define our template function. All right, because this is a truncus, we are going to be defining f of x as being a divided by bracket x minus h squared plus k. And all I can do is I can type f of x. Oh, unfortunately, I already have some variables installed. There we go, fixed. So I now have my template equation. Because I have three unknown values, a, h, and k, I need to use a simultaneous equation set with three data points. All right. Doing this by hand would have you substituting in 0 and 0 and getting values of a, h, and k, or 2 and 0.75. So what I would then do is under keyboard, if you go to math 1, there is a button that is in the middle of math 1, and I will draw what it looks like on the on the whiteboard behind me, and it looks like that, and I'm going to press it twice. So I'm going to end up with three boxes, a line, and then a third box. And what I'm going to do is I'm going to put in, using function notation, the values that I already know. So I know that f of 0 is 0. I know that f of 2 is 0.75. And I also know that f of 5 is equal to 4. And then in the box on the outside, I'm going to type a, h, k. I'm going to hit enter. And it's going to give me two possible answers. Now I'm going to convert these into fractions. One is a nice, clean number, and then the other one is utterly ridiculous. K is that, whatever the hell that is. All right? That's because we're working with truncuses. And what you'll notice is that this truncus here is a positive number. This truncus here for A is a negative number. So that means that one of my truncuses is going to be nice and, tree trunk like that. The other one is going to be like that. Now, because we kind of want a roller coaster, we want to start with a ramp, or we want to start with that flame, we want the positive one. Therefore, we just ignore the big gobbledygook mess, and we just worry about the values that we've got here. So, in the document, I would say f of x is equal to a. We've decided that a is 400 over 3. Divided by x minus a, or h, which is 10, squared minus 4 over 3. All right, and for the purposes of what we're doing, I think that is pretty close to good enough. However, if you remember how to do fraction simplification, that 400 divided by 3, you can put in, so if I retype this, and I turn it into a fraction, that 3 just drops down the bottom there. So I can go in here and I can get rid of that. 400, put 3 down the bottom, and it's fine. So now we've got our first bit. Let's define the next one. Next one says a square root function that passes through 5, 4, 6, 7, and 14, 13. All right, so that's going to be equals to a multiplied by the square root of x minus h plus k. Now, it's important to remember that when you do this on your CAS, that when you type the a and the square root, you put that times symbol in. All right, whenever you're typing a anything, you need to make sure that you are putting the times symbol in, because otherwise the CAS will get confused and not know how to solve it. So now that we've defined g of x, let's just check to make sure that it works. Yep, that's correct. Remember that the square root of something is to the power of 0.5 or the power of a half. And we're going to do the same thing. 3 values, 5, so f of 5, also g of 5 is equal to 4, g of 6 is equal to 7, and g of 14 is equal to 13. And again, we're looking for a, h, and k. These are a different a, h, and k to the ones above. And we are presented with a, h, and k like that. So on our answer sheet, we would type in here, g of x equals a minus h plus k. Well, we can go through. We know what a is. A is 3, h is 5, k is 4. Done. This next one is what I would like to call a devious trap. Because to do a cubic, you can do it in one of two ways. You can do a cubic as a polynomial form, or you can do it in inflection point form. So if I write a polynomial out, so for this, I'm going to define, now I can't use h of x because I'm using a h in a lot of other things. So what I'm going to do is I'm going to call this one j of x. If I try and do this one using ax cubed plus bx squared plus cx plus d, so j of x I'll be honest, I don't know why it's throwing a fit like this, but either way, what's going to happen is if I try and solve for 4 variables, or 4 unknowns, but I only have 3 pieces of information, it isn't going to work. So what I have to do instead is, what form of a cubic do I know that only uses 3 pieces of unknown information? Well, that is what is called inflection point form. Which is what I've got here. And in that form, I only have 3 pieces of unknown information. I have 3 pieces of information that I know. I can now go and do solving for it. J of 14 is equal to 13. J of 16 is 6.5. And J of 18 equals 0. And I'm looking for A, H, and K. And it spits out my answers for me. Again, let's put these into fractions. So, again, J of X. Well, we can go H of X. We can call it H of X. F, G, H. Makes sense, but we just can't use H of X and an unknown of H in the same equation on our CAS. All right? It doesn't like it. So A is negative 13 over 16, bracket X minus 16 cubed plus 13 over 2. So now I've got those in there. Last one, a semicircle that connects 0, 0 and 18, 0. But it does not intersect any other functions, which means that it can't be the positive. It has to be the negative. So that means we're looking for a negative semicircle function. If it goes from 0, 0 to 18, 0, that means it has a diameter of 18, which means it has a radius of 9. So using a semicircle formula, we know we can do the negative of 81 minus X minus 9, because halfway, remember, and there's our J. So now that I've got these functions here, let's go back to our CAS and we'll pop them into our spreadsheet. Oh, not our spreadsheet, our graph and table. So 400 divided by 3 bracket X minus 10 squared minus 4 over 3. Now, when you type these out, you have to make sure that they copy properly. The next one is 3 square root X minus 5 plus 4. And then the next one is negative 13 over 16 times X minus 16 cubed plus 13 over 2. Make sure that's matched what I want. And then the last one is the negative square root of 81 minus X minus 9 squared. So if I go through, I'm going to zoom out a little bit. And as you can see there, you can see all the different graphs overlapping. And if you look down on here, you will see that I have done an example of what that should look like. So the last step that we have to do is we have to put restrictions on these domains so that we can work with them, so that we can draw just what I need. Because I want to draw a pretty picture, which looks like a flame, and then from there, make it all line up. Now, if you are drawing this and yours doesn't look like a nice perfect semicircle, if you go zoom and square, it will square it up so that the distance between each of the values on X and the values on Y are the same. So to put the restrictions in, now it says, draw the truncus over 0 to 5. So for that, we need to go to Math 3 on the keyboard. If you go to the third row, fifth column, you'll get a vertical line like that. We're going to go 0 is less than or equal to X is less than or equal to 5. So now I'm going to draw that graph again, and now you can see which part of my graph is only showing up. So instead of showing up both arms of the truncus, I'm just seeing that one little bit there. And now I'm going to go through and I'm going to apply the same thing to my other values. So it says there, square root function over 5 to X to 14. And, yep. And then for the cubic, then it wants 14 to 18. So that's 14, X, 18. And then the last one doesn't need a restriction because it only goes between those values anyway. If I draw it again, I can now see that I've only got the parts that I need. Now, even though the CAS looks like it's not overlapping, even though it looks like the CAS isn't overlapping, the graphs actually are, but that's just the way the CAS draws them. They would indeed connect if you were doing this by hand. Because if I go to the Y3, so if I go to the Y3 and I go to the value of 16, 6.5, if I go to the value of 18, it actually does say 0. And if I go to my circle graph, and I do go to the value of exactly 18, it does say 18, 0, it doesn't say undefined. All right, so even though the graph doesn't draw it, it's still there. The same goes for the other points where the graphs overlap. So here, that graph does indeed overlap. It's just not being rendered by the CAS. But that point actually does exist.